Hi everyone. So up till now we have covered 9 lectures here. Up till now we have completed 9 lectures and this is lecture number 10 and we are dealing with the third chapter, coordinate systems. In coordinate systems we have completed rectangular and cylindrical coordinate system. Now from the last lecture onwards we have started a spherical coordinate system. So in this lecture also we are going to continue with spherical coordinate system, right? Okay. So in the last lecture we have seen how to construct a sphere. So we have constructed a sphere and we have imagined the sphere as a combination of horizontal circles and vertical circles. Understood? And also we have seen that the sphere is symmetric with respect to its center, right? Okay. So in order to represent any point on the surface of the sphere, we need 3 coordinates, that is r, theta and phi. So here we have seen that r represents the radius of the sphere, right? And theta, as you vary theta, you are going to move along the vertical circle, and as you vary phi, you are going to move along the horizontal circle. So you need these 3 coordinates in order to represent any point on the surface of the sphere, right? Okay. Okay. So all these things we have seen here. We have studied in detail about r and we have studied in detail about theta and phi. So here in this lecture we have to study about phi here. So what I have told here, so phi, the definition of phi remains same as in case of what? As in case of cylindrical coordinate system. As in case of cylindrical coordinate system, right? Okay. So that means here also in spherical coordinate system also phi is measured with respect to what? With respect to x-axis in anti-clockwise direction. Understood? So the definition of phi will remain same as in case of cylindrical coordinate system. The only difference is there we have considered all the horizontal circles are of same radius, whereas in spherical coordinate system the radius of the horizontal circles are going to change. That is the only difference, right? Okay. Okay, but the definition of phi will remain same as in case of cylindrical coordinate system. There we have measured phi with respect to x-axis. So here also we are going to measure phi with respect to what? With respect to x-axis. Understood? So as phi varies, you are going to move along the circumference of the horizontal circle, right? So everything will remain same here, right? Okay. Okay. So now see here. So let us consider, this is the sphere I have considered, right? Okay. Okay. So let us consider this point. Right? Okay. So this is the horizontal circle. So this is the horizontal circle I am considering. Okay. So I am considering a point on the horizontal circle. So the radius of this horizontal circle is nothing but what? Is, let us say, rho. Okay. So how we have to measure the radius of horizontal circle here? The radius of the horizontal circle is nothing but what? It is the normal distance. From z-axis to this point. So the normal distance from the z-axis to this point is nothing but what? Is nothing but rho, where rho is nothing but the radius of this horizontal circle. Right. Now if you consider this horizontal circle here, right, then the normal distance from the z-axis to this point is nothing but what? Is nothing but rho. So if you call it as rho 1, then this will become rho 2, because the radius of this horizontal circle is different and this radius and the radius of this horizontal circle is different, right? Both are not same. Understood? Okay. So here the radius of horizontal circle is nothing but what? Is nothing but the normal distance from the z-axis to this point on the horizontal circle. Understood? The normal distance from z-axis to this point is nothing but what? Is nothing but the radius of this horizontal circle. So as you move from one horizontal circle to one horizontal circle to another horizontal circle, the radius of the horizontal circle is going to what? Is going to change. So let us say this is rho 3. Understood? Okay. So like this, it is going to change as you move from top to bottom. Right? Okay. So now see here. So what is phi? What is phi? So phi is nothing but what? Phi is nothing but the angle between x-axis and rho, and it is measured with respect to x-axis. Understood? So here, if I draw a line that is parallel to what? That is parallel to x-axis. I am drawing a line parallel to x-axis. So the angle between this axis and rho is called as what? Is called as phi. Is called as phi. Right? Okay. So this angle we call it as what? We call it as phi. Right? Now here, if I draw a parallel line to x-axis, the angle between x-axis and this rho, we call it as what? We call it as phi. Right? And here, this is x-axis, the angle between this x-axis and this rho 3 is nothing but phi. Right? Okay. So the definition of phi will remain same as in case of cylindrical coordinate system. So here also it is measured with respect to x-axis. Here also it is measured with respect to x-axis in anti-clockwise direction, and it is the angle between x-axis and rho, where rho is the radius of the horizontal circle. Okay. The only difference is there in cylindrical coordinate system rho is constant, but here rho is going to vary. Right? Okay. So now see here. Now what is the range of phi here? So as you move along this horizontal circle, if you move around this horizontal circle, right? Okay. So this phi is going to change. Understood? So what is the range of phi here? The range of phi is from 0 to 2 pi. The same thing here, the definition will remain same, right? Okay. So the range of phi will be from 0 to what? From 0 to 2 pi. Now, what is the differential arc length along phi here? So let us consider here this point, right? So this is also a rho 1, right? So let us say this angle is phi 1, and this angle is phi 2. So this angle will become phi 2 minus phi 1, and let us assume phi 2 minus phi 1 is very small, so that I can represent it as simply d phi. Right? Then what is this differential arc length here? This differential arc length is nothing but what? Rho 1 into d phi. Right? So this differential arc length is nothing but rho 1 into d phi. And what is the direction of this arc here? The direction of this arc is given by the tangent drawn to this arc. In which direction? In anti-clockwise direction, like this. Right? Okay. So here the differential arc length is nothing but what? Is nothing but rho d phi a phi cap. Okay. Okay. So let us consider this as rho here, not rho 1. Let us consider this as rho. Okay. Okay. So in generally we are representing with rho, right? So the differential arc length along horizontal circle is nothing but rho d phi, and the direction is nothing but a phi cap. A phi cap is the tangent drawn to the arc in anti-clockwise direction. Tangent drawn to the arc in anti-clockwise direction. Right? Okay. But here in a spherical coordinate system, we are having what? R, theta and phi. We don't have rho. Right? Okay. We don't have rho. We are having R, theta and phi. So you have to represent everything in terms of R, theta and phi. We don't have this rho parameter. Understood? So what we can do here? See here, this rho is going to change as you move from one horizontal circle to another horizontal circle. Understood? Or I can say, as you move along this vertical circle here, the radius of this horizontal circles is changing or not? Yes or no? So as you move along this vertical circle, what is going to change? Theta is going to change. So that means as theta changes, the radius of horizontal circle is also changing, which means rho must depend upon what? Rho must depend upon theta. Right? Okay, and also if radius of the sphere increases here, if the radius of the sphere increases, then this rho value is also going to increase or not? Yes or no? If you consider a bigger sphere, then this rho value is also going to increase. So which means rho value is going to depend upon what? Rho value is going to depend upon the radius of the sphere, and also it is going to depend upon theta, right? So as r value increases, rho value is also going to increase, and as you move along the vertical circle, theta is going to vary. As theta varies, rho value is also going to vary. So that means what we can conclude here is rho must depend upon r and theta, r and theta. So how it is going to depend upon r and theta? So that's what we have to determine, right? See, we have to represent this differential arc length only in terms of what? Only in terms of spherical coordinates. Understood? So which means you have to eliminate here rho, right? So in order to eliminate rho, what we have understood here is rho can be represented in terms of r and theta, because it is going to depend upon r and theta. Okay, so how we can represent that? That's what we are going to see now. So see here, this is the center of the sphere, this is the center of the sphere O, right? And let us say this is z axis, let us say this is z axis, right? Okay, okay. So now see here, let us say this is radius r, this is radius r. The angle between z axis and r is nothing but what? Is nothing but theta, right? Okay, okay. So the normal distance, so here one horizontal circle is passing through this point. So the horizontal circle is passing through this point, right? Okay, and one vertical circle is passing through this point like this, let us assume, right? Now the radius of this horizontal circle, the radius of this horizontal circle, so this is the horizontal circle, right? So the radius of the horizontal circle is nothing but what? Is nothing but the normal distance, is nothing but the normal distance from the z axis to this point. Understood? So this is nothing but what? This is nothing but rho. So what I am saying, rho is nothing but the normal distance from the z axis to this point. So the normal distance means what is the angle between z axis and rho? The angle between z axis and rho is nothing but what? Is nothing but 90 degrees, isn't it? Okay, so rho is the normal distance from the z axis to this point, means the angle between rho and z axis must be what? Must be 90 degrees, and the distance from here to here is nothing but what? Is nothing but r, and let us say the distance from here to here, let us say the distance from here to here is z, right? Okay, let us say the distance from here to here is z. Let me confirm, right? Okay, so, or I will use another color here. So the distance from here to here, the distance from here to here is z, let us say. Okay, okay. So here we are getting what? We are getting a right angle triangle like this or not? Yes or no? So this is the opposite side, and this is the adjacent side, this is the adjacent side, and this is the hypotenuse, right? So now see here, what is rho here? What is rho? Tell me. So if I write rho by r, right? So rho is nothing but what? Opposite side. So opposite side rho divided by hypotenuse r. So rho by r, from this right angle triangle, opposite side divided by hypotenuse. So opposite to this angle theta is nothing but rho. That's why it is called as opposite side, right? And this is hypotenuse. So opposite side by hypotenuse is nothing but what? Is nothing but sine theta. So sine theta is equal to rho by r. So from here, rho is equal to what? Rho is equal to r into sine theta. So that's what we have already analyzed or not? Okay, so we have already having a guess that rho must depend upon r and theta. Yes or no? So how it is going to depend upon r and theta? That's what we have evaluated here, right? Okay, so what we got here, rho is equal to what? Rho is equal to r sin theta. So in spherical coordinate system, you have to replace rho with what? R sin theta. So which means what is the differential arc length here? Differential arc length along phi. So differential arc length along phi is how much? Tell me. Differential arc length along phi is nothing but rho d phi a phi cap, where rho is equal to what? What we got? Where rho is equal to r into sin theta, where rho is equal to r into sin theta. So replace this rho with r into sin theta. So r into sin theta d phi a phi cap. So this is the differential arc length along phi in spherical coordinate system. Understood? Okay. Okay. So here rho is not constant, it is going to depend upon r and theta. So how it is going to depend upon r and theta, that's what we have determined. Okay, so the differential arc length along phi is nothing but what here? Is nothing but r sin theta d phi a phi cap. Right? Okay. So with this we have analyzed, what do you mean by r, right? And what is the range of r, and what is the differential length along r, and also we have seen what do you mean by theta, right? And what happens as theta varies, and what is the range of theta, and what is the differential arc length along theta, right? Similarly, we have analyzed with respect to phi. So we have seen what is phi, so what happens as phi varies, and what is the range of phi, and what is the differential arc length along phi. So these things we have completed. So which means we have done a detailed analysis about r, theta and phi, right? Okay. Okay. So what are the differential lengths here? What are the differential lengths along r? The differential length along r is nothing but what? Dr ar cap, right? And the differential length along theta is nothing but r d theta a theta cap, and the differential length along phi is nothing but what? Rho d phi, where rho is nothing but r sin theta. So here r sin theta d phi a phi cap. So these are the differential lengths. In case of what? In case of spherical coordinate system. Okay, see, as you move along r, you are going to move along a straight line path. So the differential length will be simply dr ar cap. As you move along theta, you are going to move along what? Vertical circle. So you are moving along a curved path, and hence you have to get a differential arc length along theta, that is r d theta a theta cap. And next is you are going to move along what? Along the horizontal circle. So as you move along the horizontal circle, you are moving along a curved path, and hence the differential arc length along that curved path is nothing but what? R sin theta d phi a phi cap. So two curved paths, one is vertical circle and another one is horizontal circle, and hence you are having two differential arc lengths. Understood? And moving along r is nothing but simply along a straight line. So you are having another differential length along r, that is dr ar, right? Okay. 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 So r theta and phi, right? Okay. Okay. Right. So I hope up till now it is crystal clear, right? Okay. So next we will see how to represent the spherical coordinates, in terms of what? In terms of rectangular coordinates. We will see how to represent the spherical coordinates in terms of what? In terms of rectangular coordinates. So what are the spherical coordinates here? R, theta and what? And phi, right? Okay. Okay. So one more thing here I want to specify, I forgot to represent. So that is, see here, So here we got rho equal to what? Rho equal to r sin theta from this right angle triangle. Similarly, what is z here? What is z? Z is nothing but adjacent side. Yes or no? So z by r is equal to what? Is equal to cos theta. Adjacent side by hypotenuse is nothing but cos theta. So therefore here in spherical coordinate system we can replace z with what? Z with r cos theta. Okay. So make this point also. Note this point also. Okay. Rho is r sin theta whereas z is r cos theta. Okay. Okay. Yeah. Fine. Right. So now we are trying to represent the spherical coordinates in terms of what? Rectangular coordinates. So there is no need to remember any formulas and all. Just we will follow the definition of r, theta and phi. Then automatically we can get the expressions for r, theta and phi in terms of rectangular coordinates. Right? Okay. Okay. Yeah. So now see here. So now see here. Right. Okay. Okay. Yeah. So what I am saying here? Okay. So r, theta and phi. Right. Okay. Okay. So now see here. So the distance from the center to this point, the distance from the center to this point is nothing but what? Is nothing but r. Right. So this is center. Let us consider this as origin. So this origin O, we are considering it as 0, 0, 0. So this point is somewhere present in space. It is located. This point is present somewhere in space. So this is the sphere you are having. So this is the origin. So somewhere in space you are having x, y, z. Understood? So this point is present on the surface of the sphere. So which is present somewhere in space like this. Understood? So this point I can represent in rectangular coordinate system. I can represent this point as what? As some x, y, z. I can represent it as x, y, z. Now what is r here? R is nothing but the distance from the center of the sphere to any point on the surface of the sphere. So what is the distance from 0, 0, 0 to x, y, z is nothing but what? Square root of x square plus y square plus z square. Understood? So r I can represent it as what? R I can represent it as square root of what? X square plus y square plus z square. That's it. Right? Next, theta. Now see here. Okay. So now see here. Now here we are having rho equal to r sin theta, and here you are having z equal to what? Z equal to r cos theta. Or if you consider here this right angle triangle here, if you consider this right angle triangle, so from this right angle triangle, what is tan theta here? Tell me. What is tan theta? Tan theta is nothing but opposite side by adjacent side. So that is nothing but rho by what? Rho by z. Rho by z. Understood? So where this rho is nothing but what? See, this rho is nothing but the normal distance from z axis to this point. So let us say this point is lying somewhere in three-dimensional space. So this point will become x, y, z, and this point is nothing but what? 0, 0, z. This point will become 0, 0, z, and this point will become x, y, z. So rho is nothing but what? The distance from here to here. So what is the distance from 0 comma 0 comma z to x comma y comma z is nothing but root over x square plus y square. So that means I can replace rho with what? I can replace rho with square root of x square plus y square divided by what? Divided by z. So therefore from here theta is equal to what? Theta is equal to, you are going to get tan inverse of square root of x square plus y square divided by what? Divided by z. So this is the theta value. So this is theta in terms of what? Rectangular coordinates system. Okay. Okay. So we can represent theta as what? Tan inverse of what? Tan inverse of square root of x square plus y square divided by what? Divided by z. Right. Okay. Next, what is phi r? See, I have told already the definition of phi will remain same as in case of what? As in case of cylindrical coordinate system. So what we got in cylindrical coordinate system, phi is nothing but tan inverse of y by x. So here also you are going to get the same thing here. So that is tan inverse of what? Tan inverse of y by x. Understood? There is no change in that because the definition of phi will remain same as in case of cylindrical coordinate system. Understood? And hence here also we are going to get phi as what? Tan inverse of y by x. Right? So there is no need to do it again and again here. Right? Okay? Okay. So here we have represented r in terms of rectangular coordinates, theta in terms of rectangular coordinates, phi in terms of rectangular coordinates. So next we try to represent in the same manner, we try to represent the rectangular coordinates in terms of what? In terms of spherical coordinates. Rectangular coordinates in terms of spherical coordinates, that is x in terms of spherical coordinates, y in terms of spherical coordinates, and z in terms of spherical coordinates. See, already we know the value of z here in terms of spherical coordinates. See, from this right angle triangle already we have determined z value is equal to what? Z value is equal to r into cos theta. We have already determined this one, right? So you can directly write z is equal to what? Z is equal to r cos theta. Z is equal to r cos theta, right? Okay. Next, what is x and what is y? How we can write here? How we can write what is x and what is y in terms of spherical coordinate system? See here, in cylindrical coordinate system we know the relation. Yes or no? In cylindrical coordinate system, we know that x is equal to what? X is equal to rho cos phi and y is equal to what? Y is equal to rho sin phi. Right? In cylindrical coordinate system, we know x equal to rho cos phi and y equal to rho sin phi. In spherical coordinate system, the definition of phi will remain same. So phi is not going to change. Understood? But rho we can replace with what? R sin theta in case of spherical coordinate system. Understood? So we can replace rho with r sin theta. Right? Okay. Just replace rho with r sin theta in case of spherical coordinate system. Understood? So x is equal to what? X is equal to rho cos phi in cylindrical. So if you want to represent in spherical, just replace rho with r sin theta. So then you are going to get what? R sin theta cos phi. Next, y is equal to what? Y is equal to rho sin phi. In spherical coordinate system, phi will remain same, whereas rho you can replace with r sin theta. So you are going to get what? Y is equal to r sin theta sin phi. Y is equal to r sin theta sin phi. Understood? Okay. So this is how we can represent the spherical coordinates in terms of what? Rectangular, and rectangular coordinates in terms of what? In terms of spherical. Right? Okay. Okay. So I hope it is crystal clear here. I hope it is crystal clear. Right? Okay. So after this what we have done here in cylindrical coordinate system, whatever the steps we have followed. Okay. So in the same manner we are going to develop in a spherical coordinate system also. Right? Okay. Okay. So now see here. So there we have represented aero cap and a phi cap, aero cap and a phi cap in terms of what? In terms of phi. Right? Okay. We have seen that the directions of aero cap and a phi cap are changing with respect to phi. So as phi varies, we have observed that the directions of aero cap and a phi cap are changing. Right? So here also in spherical coordinate system, what are the unit vectors you are having? Unit vectors you are having are nothing but AR cap and A theta cap and what? And A phi cap. Understood? Okay. So the definition of A phi cap, this definition of A phi cap will remain same as in case of cylindrical coordinate system. Okay, so that means whatever the expression we got in case of cylindrical coordinate system, the same expression is valid in spherical coordinate system also for A phi cap. Okay, so now our task is to determine this AR cap and A theta cap, right? Okay. So how to determine this AR cap and A theta cap? So I have told you a trick here, how to represent this AR cap and A theta cap. I have already told you a trick how to represent this unit vectors, right? Okay, so what is the trick here? So what I have told, so take the differential length DL bar in rectangular coordinate system, that is DL bar is equivalent to dx AX cap plus what? Plus dy AY cap plus what? Plus dz AZ cap. Take the differential length in rectangular coordinate system. Then what I have told here? So on LHS side, try to determine the differential length. By varying only r. So by varying only r, the differential length you are going to get here is nothing but what? Is nothing but dr AR cap. If you try to determine the differential length by varying only r, then you are going to get the differential length as what? Dr AR cap. So since you have determined the differential length by varying only r on LHS side, on RHS side also you have to determine dx by varying only r. Similarly, you have to determine dy by varying only r. Similarly, you have to determine dz by varying only r. Okay, so how we can determine that here? See here. So we know that x is equal to what? We know this relation here. X is equal to r cos theta. X is equal to r sin theta. X is equal to, you remember like this, x is equal to rho cos phi. Rho is nothing but r sin theta. Okay, so x is equal to r sin theta cos phi, and y is equal to what? Y is equal to rho sin phi, where rho is nothing but r sin theta. So that is r sin theta into what? Into sin phi, and z is equal to what? Z is equal to r cos theta. Right? Okay. So here we are trying to determine what? Here we are trying to determine AR cap. Okay, we are trying to determine AR cap. So the differential length that we got by varying only r on LHS side is nothing but dr AR cap. So on RHS side also we have to determine dx, dy and dz by varying only r. Okay, so that we can determine with the help of these relations. So now here what you have to do here? So you have to differentiate on both sides with respect to what? With respect to r. You have to determine dx by varying only r and keeping theta and phi constant. You have to determine dy by varying only r and keeping theta and phi constant. You have to determine dz by varying only r and keeping theta and phi constant. Understood? That's what we have to do. So now take this relation and differentiate on both sides with respect to what? With respect to r. So then what you are going to get? You are going to get dx by dr is equal to what? Is equal to sin theta cos phi. So dx is equal to, you are going to get dr into sin theta into cos phi. Right? Similarly here, if you differentiate on both sides with respect to r, what you are going to get? You are going to get dy by dr is equivalent to what? Sin theta into what? Into sin phi. So therefore dy is equal to what? Dy is equal to dr into sin theta into what? Into sin phi. Now similarly here, if you differentiate on both sides with respect to r, you are going to get dz by dr is equivalent to what? Is equivalent to cos theta. So dz is equal to what? Is equal to dr into cos theta. Okay, so we have determined dx, dy and dz by varying only r and keeping theta and phi constant. Understood? Okay, so what you are going to get, tell me here. So here this is equivalent to what? So dx is nothing but what? Dx is nothing but dr sin theta cos phi. So dr sin theta cos phi ax cap plus what? Plus. So dy is nothing but dr sin theta sin phi. So dr sin theta sin phi ay cap plus dz is nothing but what? Dr cos theta. Dr cos theta az cap. So on both sides here, on both sides, what is going to get cancelled? This dr will get cancelled on both sides. This dr will get cancelled on both sides. Okay, so therefore ar cap, therefore ar cap is equal to what? Ar cap is equal to what you are going to get? Sin theta cos phi ax cap. So sin theta cos phi ax cap plus what? Plus sin theta sin phi ay cap plus what? Plus cos theta az cap. Right? So this is the expression we are going to get for what? For ar cap. So from here we can say that ar cap is depending upon what? Is depending upon both theta as well as what? As well as phi. So as theta and phi varies here, as theta and phi values varies, the direction of ar cap is also going to vary. Understood? Okay. So ar cap is equal to what? What we got? Sin theta cos phi ax cap plus sin theta sin phi ay cap plus cos theta az cap. Okay, so this is the dependence of ar cap on theta and phi. See, only in rectangular coordinate system the directions of unit vectors are fixed. Ax cap will always point along parallel to x axis, ay cap will be always parallel to y axis, az cap will be always parallel to z axis. Understood? So in cylindrical coordinate system, the direction of aero cap and a phi cap are going to change as phi varies. Right. In the same manner, in spherical coordinate system also, the directions of ar cap, a theta cap, a phi cap, all are going to change here. All are going to change. So the directions of ar cap and a theta cap are going to depend upon theta and phi, and the directions of a phi cap is going to depend upon phi. Right? Okay. Okay. Yeah. So we have determined the dependency of ar cap on theta and phi. So next we try to determine, in the same manner we try to determine for a theta cap. So next we try to determine for a theta cap. So what is the first step here? So first write down the differential length in rectangular coordinate system. Dx ax cap plus what? Plus dy ay cap plus what? Plus dz az cap. Right? So on LHS side, this is LHS and this is RHS, right? So on LHS side, try to determine the differential length. Try to determine the differential length by varying only theta. By varying only theta and keeping r and phi constant. See, by varying only theta means by default you have to understand that r and phi are constant. Understood? So there is no need to say every time r and phi are constant and all these things. Okay. So whenever I am saying the differential length by varying theta means by default you have to understand that r and phi are constant. Right? Okay. Okay. So what is the differential length? What is the differential length that we are going to get by varying only theta here? By varying only theta, the differential arc length that we are going to get is nothing but what? Is nothing but r d theta a theta cap. Yes or no? So by varying theta, by varying theta, the differential length that we are going to get is nothing but what? R d theta a theta cap. So on RHS side also we have to determine dx, dy and dz by varying only theta, by varying only theta. So in order to do that, what we have to do? So you have to use this relation. So that is x is equal to what? X is equal to r sin theta cos phi, and y is equal to what? Y is equal to r sin theta sin phi, and z is equal to what? Z is equal to r cos theta. Okay. Okay. So now what we have to do? What we have to do? You have to determine dx, dy and dz by varying only theta. So which means here you have to differentiate on both sides with respect to what? With respect to theta. So if you differentiate on both sides with respect to theta, what you are going to get? Dx by d theta is equal to what? R into cos theta cos phi. So therefore dx is equal to r d theta into cos theta into cos phi. Right. And here if you differentiate on both sides with respect to theta, what you are going to get? Dy by d theta, which is equal to what? Which is equal to r into cos theta, r into cos theta into sin phi. So therefore dy is equal to what? R d theta into what? Into cos theta into sin phi. Right. And here if you differentiate on both sides with respect to theta, what you are going to get? Dz by d theta is equal to what? Differentiation of cos is minus sin. So you are going to get minus r sin theta. So therefore dz is equal to what? Dz is equal to minus r d theta into what? Into sin theta, into sin theta. Right. Okay. Okay. So therefore here just replace dx with r d theta cos theta cos phi, and replace dy with r d theta cos theta sin phi, and replace dz with minus r d theta sin theta. Right. Okay. So if you observe here, this is r d theta a theta cap, and here plus of this one. So these are the terms that we got. Right. Okay. So if you observe on both sides, this r d theta will get cancelled. Right. Okay. So finally what is left out here? Tell me what is left out. So a theta cap. So finally we got a theta cap is equivalent to what? A theta cap is equivalent to cos theta cos phi ax cap. Okay. So cos theta cos phi ax cap plus what? Plus cos theta sin phi ay cap minus sin theta az cap. Correct now? So cos theta sin phi ay cap and minus sin theta az cap. So this is the expression we got for a theta cap. So if you observe, a theta cap is also depending upon what? Both theta and phi, Understood? Okay. Okay. So this is how you have to determine AR cap and a theta cap. See, there is no need to do again for a phi cap here, because the definition of phi will remain same as in case of what? As in case of cylindrical coordinate system. So you can directly write a phi cap. Whatever we got in cylindrical coordinate system, the same result you are going to get. So if you want, you can check here, follow the same procedure, and if you want, you can check, you are going to get the same answer. So that is a phi cap is equal to, you are going to get minus sin phi ax cap plus what? Plus cos phi ay cap. Okay. So this is the result you are going to get. So there is no need to do it again. Okay. Okay. If you want to practice, then you can just follow the same procedure, and finally you are going to end up with the same result. Right. Okay. So here we have written AR cap and a theta cap and a phi cap. Right. Okay. So in this lecture we have studied about phi. Right. So we have studied about phi, and then we have started representing these unit vectors ar cap, a theta cap and a phi cap, right? Okay, so whatever the procedures we have followed in cylindrical coordinate system, the same procedures here also we are following. So I hope you become familiar with these procedures, right? Okay, okay. So with this I am winding up the session here. With this I am ending up this session, right? With this I am ending up the session, right? Okay, so we will continue this spherical coordinate system in the next lecture also, right? So up till now I hope it is crystal clear. So I hope you know what do you mean by r, what do you mean by theta, and what do you mean by phi, and how to represent the unit vectors and all these things, right? Okay, so I hope each and everything is crystal clear, and I hope you are enjoying my lectures, right? So okay, then take care, bye bye, and thank you